Hello and welcome back to our discussion of the respiratory system. In this video, we will be talking about pressure and volume changes during ventilation. Okay, so basically in this section, we are addressing the question, how do we get air to move into and out of our lungs? And to do this, I would like you to consider this gas law right here, right? So remember that gases are going to move from areas of high pressure to areas of low pressure. Taking that into consideration, think about what are we going to need to do with pressures in order to move air into our lungs? And what are we going to need to do with pressures in order to move air out of our lungs? So take a moment to think about that. Okay, so hopefully you figured out that in order to get air to move into and out of our lungs, we are going to need to create pressure gradients, okay? So in order to move air into our lungs, what we need to do is we need to make the pressure in our alveoli or inside of our lungs be less than the pressure in our atmosphere, okay? And then in order to move air out of our lungs, we're going to need the pressure in our alveoli to be greater than the pressure in the atmosphere. That way the air will move out from the inside of our lungs to the atmosphere, okay? So how do we do this physically with our bodies, okay? Let's talk about that. So we're gonna start by addressing inspiration, okay? Again, remember that in order to get inspiration to happen, we're going to need the pressure in our alveoli to be less than the pressure in the atmosphere. How are we going to achieve this? I want you to think about that, but I will also remind you of Boyle's law, right? So remember, we're going to start with a certain pressure and volume in our lungs. We want to make the pressure in our alveoli low. So what are we going to need to do with the volume in order to get that to happen? Think about that for a second. Okay, so hopefully you figured out that in order for P2 to go down, in order for our new pressure to be lower than our kind of starting pressure in our lungs, we are going to need to increase our volume of our thoracic cavity, okay? Once we increase the thoracic volume, that's going to decrease the pressure in our alveoli, and then that's going to allow air to move down its pressure gradient from the atmosphere, where the pressure is higher, into our lungs, where the pressure is lower, okay? How do we actually physically change the volume of our thoracic cavity? We use our respiratory muscles, okay? So one thing we do is we contract our diaphragm, okay? The diaphragm, again, is at the bottom of the thoracic cavity. When we contract it, it moves downwards. And as you can imagine, as we move our thoracic cavity, as we move our diaphragm downwards, that's going to increase the volume in our thoracic cavity. The other thing we do is that we contract our inspiratory muscles, okay? So our inspiratory muscles, basically their action is to lift the rib cage up and kind of out, kind of like pivot them, like pivot the bottom forward like this, okay? So you can kind of try this yourself, breathe in and feel what your ribs are doing, okay? So that's how we breathe in. Now let's take a look at expiration. So again, to remind you, in order to expire, in order to get air to move out of our lungs into the atmosphere, we need the pressure in the lungs to be greater than the pressure in the atmosphere. That way the air will follow its pressure gradient out into the atmosphere. How do we achieve this? Using Boyle's law. Again, we're starting with a certain pressure and volume. We want to make the pressure high in the alveoli. So what are we going to need to do with the volume? Think about that. Okay, so hopefully you figured out that we are going to need to decrease the volume of the thoracic cavity in order to increase the pressure in the alveoli. Once we do that, our pressure in the alveoli is going to be higher than the pressure out in the atmosphere, and then air is just going to follow its concentration gradient, its pressure gradient from our alveoli out into the atmosphere, and we will be able to expire. Okay. Um, when we do quiet breathing, like normal breathing, our expiration, our decrease in thoracic cavity volume does not actually require any effort. Okay, so basically, the way that we decrease our thoracic cavity volume is basically just to relax our inspiratory muscles and then also to rely on our natural lung recoil. So I want to remind you that the lungs are kind of like balloons. We have put in effort to stretch that balloon. And then when we sort of release that effort, the balloon will naturally snap back to its original position. So the lungs have a tendency to want to collapse, sort of. Okay. So quiet expiration is passive. Okay. No effort required. However, you also know from our discussion of lung volumes that it is possible to have active expiration in which we put in additional effort to push out additional air from our lungs. Okay, so we do that by further decreasing our thoracic volume. And the way that we further decrease our thoracic volume is by contracting some muscles. Okay, so what muscles are we contracting? We have these, don't worry about the name, but we have our expiratory muscles that are going to kind of bring, so if these are your ribs, they're kind of going to bring your ribs down and in like this, okay, to decrease that volume in your thoracic cavity. Another thing that we're going to do is we're going to contract our abdominal muscles. So contracting our abdominal muscles pushes the abdominal wall in, and that is going to decrease the volume in there. Okay, again, I want to encourage you to try that yourself and see if you can feel those motions in your thoracic cavity, in your ribs. And that is the end of this section.